everyone. I am Shivani Trivedi from ABES Engineering College, Ghaziabad. Today in this video, we are going to discuss about transmission impairment. So these are the topics that I am going to discuss in this video. That is what is transmission impairment? What are the causes of transmission impairment, which are attenuation, distortion, noise. So basically, what is transmission impairment? When the signal travels through the transmission medium, which are not perfect, all transmission medium are not perfect, due to which your signal get distorted. What you are sending is not exactly what you are receiving. So what is sent is not what is received. So this is the transmission impairment. So we will see what are the causes of transmission impairment. So there are three causes, basically three important causes for transmission impairment are attenuation, distortion, noise. We will see each one in detail. What is attenuation? Attenuation means loss of energy. Loss of energy. When we send any signal, whether it is simple or composite, it travels through a medium and it lose some of its energy in overcoming some resistance of the medium. So that is why sometimes you see a wire carrying the electric signal get hot for some time. So this is the reason. Attenuation is the reason that your electrical energy is converted to heat. To compensate this attenuation, we will use amplifier to amplify the signal. You can see here, we will say original signal is this, attenuated signal due to loss of energy is this. If we use amplifier, then we will get the amplified original signal. Now, one more point is that सिग्नल का लॉस हुआ है या सिग्नल की स्ट्रेंथ में गेन हुआ है, तो ये दोनों चीज हम मेजर करते हैं. यूनिट है आपकी डेसिबल. Engineer uses this unit to measure the relative strength of two signals or one signal at two different points. So we will measure this in decibel. If the value of the decibel is negative, that means signal is attenuated. If the value of the signal, if the signal, if the decibel is positive, that signal is amplified. So remember this for the numerical. Now we will see some question on this. A signal travels through a transmission medium and its power is reduced to half. मतलब P2 equal to half of P1. Formula is this of dB decibel. dB equals to 10 log base 10 P2 by P1. As I already told you, decibel measure the relative strength of two signals at two different points or one signal at two different points. So P1 and P2 are the power of the signal at point 1 and point 2. So by applying this, we will solve this. 10 log 10 P2 by P1. P2 is 0.5 of P1. So 0.5 P1 upon P1. Log 0.5 is approx 10. Its value is minus 0.3. So it is minus 3 decibel. So value of decibel is negative. It means there is a loss of signal. Remember this formula. Next, a signal travels through an amplifier and its power is increased 10 times. That means P2 equal to 10 of P1. Okay. In this case, the amplification gain of power can be calculated as decibel की value यहाँ positive आएगी. So formula है dB equal to 10 log base 10 P2 by P1. P2 is 10 of P1, 10 log base 10, 10 of P1 upon P2. What is this? 10 decibel. The value is positive. Next. In this figure, you can see that a signal travels from point 1 to point 4, but from point 1 to point 2, value is negative. It means signal is attenuated. By applying the amplifier, signal get amplified, value is positive. Point 3 to point 4, signal again get attenuated. Tell me the decibel value. But in this case, the decibel value can be calculated by cascading. So what is the decibel value? dB equals to minus 3 plus 7 -3. So what is the total value? dB equals to +1. -3 पहले एटीन्यूट हुआ, फिर एम्पलीफाइड हुआ, फिर से एटीन्यूट हुआ, सबको कैस्केड कर दो और आपकी वैल्यू आई +1. सो सिग्नल हैज गेन द पावर. इन टोटल हम कंक्लूड कर सकते हैं कि सिग्नल ने पावर गेन करी बिकॉज डेसिबल की वैल्यू यहाँ पॉजिटिव है. नेक्स्ट, समटाइम डेसिबल की वैल्यू को हम मिली वॉट्स में भी, डेसिबल इज यूज टू मेजर सिग्नल पावर इन मिली वॉट्स में भी कैलकुलेट करते हैं, तो उसको बोलते हैं मिली वॉट्स में डीबी सबस्क्रिप्ट में एम. तो फॉर्मूला है dBm इक्वल्स टू 10 log, इट इज गिवन pm. पावर या मिलीवॉट्स में कैलकुलेट द पावर ऑफ अ सिग्नल. dBm दे रखा है आपको -30 इक्वल्स टू 10 log बेस 10 pm. आपको pm कैलकुलेट करना है, तो pm यहाँ से वैल्यू कैलकुलेट होके आएगी 10 रेज टू पावर -3 मिलीवॉट. कैलकुलेट करना आप. नेक्स्ट, द लॉस ऑफ केबल इज यूजुअली डिफाइंड इन डेसिबल पर किलोमीटर. If the signal is at the beginning of the cable is -0.3 decibel per kilometer, उसकी पावर है 2 मिलीवॉट. व्हाट इज द पावर ऑफ द सिग्नल एट 5 किलोमीटर? 5 किलोमीटर. तो लॉस कितना हुआ केबल का? लॉस के ऑफ द केबल इन डेसिबल 5 किलोमीटर से 1 किलोमीटर की 0.3 है, तो 5 किलोमीटर की 5 इंटू -0.3, दैट इज योर -1.5 डेसिबल. नाउ वी विल कैलकुलेट द पावर एज dB equals to 10 log base 10 P2 by P1 और इट इज गिवन एज 1.5 इक्वल टू dB की वैल्यू क्या दे रखी है अपन को? 1. अभी ने कैलकुलेट करी 1.5 -1.5 सॉरी -1.5 10 log 10 P2 by P1. P2 equals to 0.71 of P1 and it is, what is P1? P1 is 2 milliwatt. So 0.71 into 2, that is your 1.4 milliwatts. So this is the total answer. P2 की मतलब power of the signal as 5 kilometers is 1.4 milliwatt. Now next cause is your distortion. Distortion means signal changes its form, signal change its shape or form. ये होता क्यों है? जब sender composite signal भेजता है. What is composite signal? It is basically a collection of simple sine waves. Sine waves के collection को उसी को बोलते हैं हम कंपोजिट सिग्नल्स. अब हर एक सिग्नल की कंपोजिट सिग्नल अलग अलग फ्रीक्वेंसी के सिग्नल से बना हुआ है. तो सेंडर ने भेजा बट रिसीवर पे उसने अपनी शेप डिस्टॉर्ट हो गया, उसने अपनी शेप चेंज कर दी, अपनी फॉर्म चेंज कर दी. ये हुआ क्यों? बिकॉज डिफरेंट डिफरेंट सिग्नल, डिफरेंट डिफरेंट फ्रीक्वेंसी के सिग्नल है कंपोजिट सिग्नल में. जब वो मीडियम से ट्रेवल करते हैं तो सबकी अलग अलग प्रोपगेशन स्पीड होती है. तो डिफरेंस इन द डिले कॉजेज द डिफरेंस इन डिले एट डेस्टिनेशन. सब अलग अलग टाइम पे पहुंच रहे हैं, उस वजह से आपका क्या होता है? डिस्टॉर्शन. एंड दिस कॉजेज द चेंज इन द शेप ऑफ द सिग्नल एट रिसीवर साइड. So this is a distortion. Next is your noise. Noise is another cause which like you have seen about different type of noise like thermal noise, like induced noise, different impulse noise, crosstalk. Like thermal noise is caused in the wire due to the random motion of the electrons. उसकी वजह से आपका extra signal create होता है, original signal से overlap होके इसमें noise आ जाता है. Induced signal is because of some motor or because of the sound of some motor or appliances called the induced noise. Crosstalk is one wire can affect the signal of another wire. If both the wire are parallel, then this can cause the crosstalk. Impulse noise is when there is a sharp spike with high energy in a very short time that come from power line, like lightning. This called the impulse noise. So these noises also distort the signal at the receiver side. So for this, we will calculate the SNR ratio. What is SNR ratio? SNR ratio का formula है average signal power upon noise power. Why we are taking here average? Because these power changes with the time. So that is why we are taking here the average signal power upon average noise power. So SNR is the ratio of two powers. So it is often described in decibel unit. So if it is described in decibel unit, then it becomes SNR dB. And what is the formula for that? 10 log base 10 or SNR. अगर आपको सिर्फ एसएनआर कैलकुलेट करने को है तो आप सिग्नल पावर अपॉन नॉइस पावर करेंगे। अगर आपको एसएनआर इन डेसिबल पूछा है तो पहले आप एसएनआर कैलकुलेट करें, उसके बाद 10 लॉग एसएनआर करें। कुछ एग्जाम्पल देख लेते हैं। द पावर ऑफ अ सिग्नल इज 10 मिलीवॉट एंड द पावर ऑफ द नॉइज इज 1 माइक्रो वॉट। व्हाट इज द एसएनआर? पहले एसएनआर पूछा है तो नॉर्मल एवरेज सिग्नल पावर अपॉन नॉइस पावर। सिग्नल पावर इज 10 मिलीवॉट, तो उसको एक को माइक्रोवॉट में कन्वर्ट कर देते हैं, अपॉन नॉइस पावर दैट इज 1 मिली माइक्रोवॉट। ओके, देन इट बिकम 10,000। SNR is 10,000। What is SNR dB? भी फॉर्मूला देखा हमने, इक्वल टू 10 log 10, 10,000, दैट इज योर 10 log 10 की पावर 4, दैट इज 40 SNR dB. Next, what is the value of SNR and SNR-TB for noiseless channel? Noiseless channel means noise equal to 0. What become SNR equal to signal power upon noise power, which is your 0, then SNR become infinite. SNR-TB equal to 10 log 10 infinite. What is it? Infinite. So we can never achieve this ratio in real life. It is an ideal condition. So these are the references that I refer for this video. Thank you for your patience listening.